Hello everyone, welcome to the Learning Royal. Teacher 1 here. Today we'll be taking a look at AMC 8 2020 problems 16 through 20. This is the final video in the AMC 8 2020 series. Now Teacher 2, take over.
Hello everyone, Teacher 2 here. So let's look at the first problem. Each of the points A, B, C, D, E, and F in the figure below represents a different digit from 1 to 6. Each of the 5 lines shown passes through some of these points. The digits along each line are added to produce 5 sums, or 1 for each line. The total of the 5 sums is 47. What is the digit represented by B? So here, if we look at this problem, first let's label these lines. Okay, so here the orange line here represents line 1, which we can conclude is A plus B plus C. Line 2, which is indicated by the red line, is A plus F plus E. Line 3, which is indicated by the yellow line, is B plus D. Line 4, which is represented by the blue line, is C plus D plus E. And line 5, which is the green line in the figure, is B plus F. So the total of all of these 5 lines, 2A plus 3B plus 2C plus 2D plus 2E plus 2F, is equal to 47, because the total of the 5 sums is 47. Now, if we look at this, we can say that 2 times the sum of A plus B plus C plus D plus E plus F plus B is equal to 47, since every letter is being multiplied by 2 except for B, which is being multiplied by 3, and we get this total sum of 47. The last part of this problem, in order to solve it, is that A plus B plus C plus D plus E plus F is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6, because we have to use a different digit from 1 to 6 for each of these 6 points. So all of these 6 points together will give us a sum of 21. Now, if we replace that in our original equation, we get that 2 times 21 plus B is equal to 47, and then we can further simplify this and solve for B. 42 plus B equals 47, and therefore B equals 5, which means that the answer is E, 5.
Okay, let's go on to the next problem. How many factors of 2020 have more than 3 factors? As an example, 12 has 6 factors, namely 1, 2, 3, 4, 6, and 12. So first, let's try to find out the factors of 2020. Well, to do so, we have to find the prime factorization of 2020 first. So the prime factorization of 2020 is 2 squared times 5 times 101. Now, to find out the factors, so first, each and every one of 2020's factors can be written in a specific form, which is 2 to the either 0 power, 1 power, 2 power, times 5 to the either 0 or 1 power, times 101 to the either 0 or 1 power. Any of, if 2 is to the 0th power, 5 is to the 1 power, for example, and 101 is to the 1 power, that's still a factor. So those are all gonna be factors of, and those are all gonna be factors of 2020. So that's the form of any factor. Well, now we can use this to calculate the number of factors, because there are 3 ways for us to use the power of 2. It can be either 0, 1, or 2. There are 2 ways for us to choose the power of 5, which is 0 or 1. There are 2 possible values. And there are 2 ways for power 101, which is 0 or 1. We can pick any one of them. So there are a total of 3 times 2 times 2 ways, which is 12 ways, meaning that 2020 has a total of 12 factors. Okay, so since we know that 2020 has a total of 12 factors, let's try to find how many factors of 2020 have less than or equal to 3 factors, since that's probably going to be easier. So factors of 2020 with 1 factor, that's only 1. Factors of 2020 with 2 factors, those are the prime numbers, which is 2, 5, and 101. And factors of 2020 with 3 factors, those are the perfect square numbers, such as 4. So 4 is one of our values. Now, the total number of these factors of 2020 with 3 or less factors is 1, which are 1, 2, 5, 101, and 4. Those are 5 factors. And to find the number of factors of 2020 with more than 3 factors, you have to find the total number of factors minus total factors with 3 or less factors. The total number of factors minus the total factors with 3 or less factors, which is 12 minus 5, which is equal to 7. So our answer is B, 7. Continuing on to the next problem. Rectangle ABCD inscribed in a semicircle with diameter FE as shown in the figure. Let DA equal 16. Wait a second. Let DA equal 16 and let FD equals AE, which is equal to 9. What is the area of ABCD? So ABCD is this square we have here, not square, this rectangle we have here. Well, let's just copy this diagram down here, and so we can see it more clearly. So we can see that the radius of the semicircle is 17 because 9 plus half of the base of this rectangle, 8, which is 8, is 17, and that's true for the opposite side too. So we can say that this radius is 17. Well, we can reposition the radius so we can find out more information about it. So radius, because we were trying to find out the area of this rectangle, basically the height of the rectangle, we can reposition the radius like this. Now we can also notice that half of the base is 8. So since half of the base is 8, it's a yellow line. I know you can faintly see it, but that's the one. So since half of the radius is 8, and there's a radius of 17, half of the base is 8 and there's a radius of 17, we can see a right triangle. Well, to solve for the right triangle, we can use the Pythagoras theorem, which is a squared plus b squared equals c squared. So that's x squared, which is our value which we're trying to find, plus 8 squared is equal to 17 squared. Well, if we plug the values in, we'll get that x is equal to 15. So our length is 15. Now to find the area of the rectangle, we multiply the two sides, which is 16 and 15, which is equal to 240. So our answer is 8, 240.
Let's go on to the next problem. A number is called flippy if its digits alternate between two distinct digits. For example, 2020 and 37373 are flippy, but 3883 and 123123 are not. How many 5-digit flippy numbers are divisible by 15? So first, we want to find out what numbers are exactly divisible by 15. And if you notice that the last digit of those numbers are either 5 or 0. Okay, so our last digit can be either 5 or 0, and since it's a 5-digit number and the last digit is 5 or 0, the first, third, and fifth digit of the number is 5 or 0. Okay, so since we're looking at this number here, which is 0 blank 0 blank 0, it cannot be a possible answer because 0 cannot be the first digit, or else it would be counted as a 4-digit number. So that means we can cancel out 0 as one of our numbers in the solution. So now we can see that this needs to be divisible by 3. The 5 blank 5 blank 5 needs to be divisible by 3, so that is divisible by 15. Now, in order to find that, we can say the sum of the digits has to be divisible by 3. So we need to find numbers that are agreeing to this rule. So in this case,
by the way, if you don't understand why the sum of the digits has to be divisible by 3, that's the divisibility rule which you have to use.
Okay, so since we know this divisibility rule is true, we can say that the possible values of these numbers are either 50505, 53535, 56565, or 59595. So that means that there are 4 possible values, which is B. Now let's go on to the last and final problem. A scientist walking through a forest recorded as integers the heights of 5 trees standing in a row. She observed that each tree was either twice as tall or half as tall as the one to its right. Unfortunately, some of her data was lost when rain fell on her notebook. Her notes are shown below, with blanks indicating the missing numbers. Based on her observations, the scientist was able to reconstruct the lost data. What was the average height of the trees in meters? Okay, so now since we have this data here, we know that tree 2 is 11 meters. Now if we backtrack to tree 1, we can say that it has to be 22 meters here, since the length has to be in meters and it has to be an integer. So it cannot be 11 divided by 2. It has to be 11 times 2. And this will be the same for tree 3, where we have to multiply by 2 and not divide, since we do not get an integer value when we divide by 2. And now when we get to tree 3 and we want to move on to tree 4, this gets a little complicated, because we can either divide by 2 or multiply by 2 in that case. So we either get 11 or 44 meters. And then for tree 5, we have two possibilities of 22 or 88 meters. So now, if we look at this case here, where we add all the combinations that are possible. So we know the first three numbers are going to be 22, 11, and 22. So we have to add those first. And then we have the possibilities of 11 plus 22, 44 plus 22, 11 plus 88, and 44 plus 88. So if we add all of these together, if we add these all individually, we get first a situation where we add 11 and 22, we get 88. And in order to find the average of the 4 trees, we need to divide 88 by 5, since the average is calculated by finding the sum of all the trees and then dividing by the number of trees that are present in the data. So 88 divided by 5 would give us 17.6. However, the average height has to end in a decimal value that is 2/10 of a meter. So in this case, 17.6 doesn't have a value of 2/10. It has 6/10 in its decimal portion. So we cannot consider this as a right answer. Now if we go on to the second case, we see here that where 44 and 22 meters of trees are present, the sum is 121. In this case, 121 divided by 5 to find the average is 24.2 meters, which agrees with our average height of 0.2 of a meter. Now let's check our other solutions to make sure we're getting the right answer here. So if we go on to the third possible combination of 11 and 88, here we see that it sums up to 154. And 154 divided by 5 is 30.8, which is not agreeing with our 2/10 of a meter rule. Now if we go on to the fourth and final case, we see here that the 44 meter and the 88 meter tree, it adds up to 187. And 187 divided by 5 is 37.4 meters, which does not agree with our 0.2 meter rule. That means we can rule out 3 cases and our second case, in which the average height of the trees is 24.2 meters, which is answer B.
Thank you everyone for watching. I hope you enjoyed it. Please make sure to like, share, and subscribe. Thank you.